We're going to try prove this trig identity. And the first two things we notice really quickly is that tan I can change to sine over cos, and sine 2x I don't have to think hard at all like I do sometimes with cos, because there's just one option. And so I'm going to dive straight in with working out the left hand side. So it's 2 tan, which is sine over cos, minus, and then I'm going to do the expansion, and that is all over 2 sine squared x. What's ending up happening on the top line is that I've got a common denominator now, and so I'm going to fix up the top line for a sec and just get everything over cos. So just on the top line I'm going to get everything over cos, so this whole term here needs an extra cos, so that's where you'll start seeing cos squared, because it had an extra cos, and that's all over cos x. So that's your numerator, and then on the bottom I've got this term basically over 1, and I don't have a triple decker bus going on here, and so I'm rather going to flip this fraction so that on the top line I'm just working on 2 levels. Whenever I feel stuck in maths, it's the F word of maths, it's factorize. So on the top line I'm feeling a little bit stuck as to what's going to go on here. I'm looking at the cos squared thinking it could become 1 minus sine squared, but I'm not going to rush to that. Let me just take out a highest common factor to start with, and I'm left with that on the numerator, and on the denominator, if I put these two terms and times them together, I've got 2 cos x sine squared x. My brain is buzzing when I start seeing squareds, because I'm thinking this could just be a identity. So 1 minus cos squared changes to sine squared. So this, which becomes sine squared, it's going to cancel with the sine squared at the bottom. The 2 is going to cancel with the 2, and I'm just left with sine over cos, which is tan x. And by doing that, I've proved the identity.